So we're going to continue on with chapter 15. Just a reminder, I'm here for you with office hours. If it's not a live office hour, you can still either email me or write your questions in the Google Doc that's right underneath my office hours on the bulletin board on that first page where you got your syllabus and where you get all your notes for class and stuff from. You can click on that. If it's during office hours, I'll be there right there to answer your questions. If it's not during office hours, then just leave me the question and I will email you back. Or respond back, sorry. But yeah, so don't feel weird to like reach out and ask for help, okay guys? Like I know it's gonna be hard transitioning, but ask for help if you're getting confused. So far we've been talking about equilibrium constants in terms of concentration. So with our Kc, we've had concentration of the products over concentration of the reactants. Now we're gonna talk about, instead of concentration, can we do it with pressure? So in a constant volume reaction, partial pressures change as the concentrations change. So at constant temperature, my pressure is proportional to concentration. So let's look how we figure that out. So we all know the ideal gas law, because we already did that. So PV equals nRT. But let's rewrite that for a specific gas. So if it's a specific gas, it's going to be his partial pressure. Volume is the same because it's the volume of the whole container. And his moles times R times T. Now I want to know how pressure relates to concentration. What is the units of concentration? Yep, moles over liters. So I have moles here, and I have volume, which can be in the units of liter. So let me rearrange this. Let me push this over here so that now it's going to be moles over liters. So partial pressure of my gas would be NaRT divided by V. Now I can rearrange that so that the V is right here. And this guy is just moles over liters, which is my concentration. So PA is equal to the concentration of A times RT. So what that means is instead of using concentration, now I can use pressure in my K equation. So now we're going to talk about another K. Instead of Kc for concentration, it's going to be Kp for pressure. But it's very similar. So it's not, So let's look at a gas phase reaction. So same thing. I've got my reactants A and B, my products C and D. These are my coefficients, but they're all gases. So now I can write my Kp. So P because we're talking about pressure, okay? So Kc was for concentration, Kp is equal to the pressure for gas C raised to the C. The pressure of gas D raised to the D. The pressure of A to the, lowercase, to his coefficient, and the pressure of B to his coefficient. So it's the same, besides that it's P instead of Kc, and it's not brackets, it's parentheses, because brackets mean concentration. So just parentheses, and we're talking about pressure, but it's still of whatever the products are in the reactants, and then their coefficients. So C, D, A, and B. Now, we might want to know, well, how does Kp and Kc relate? We looked at it earlier, and we noticed that concentration and pressure related here by RT. So if I know my Kc or my Kp, I can actually find the other one. So here's the equation that relates the two. Kp is equal to Kc times RT, and that is raised to the delta N gas. That's just one thing, delta N gas. So Kp is equal to Kc times RT raised to the delta N gas. All right, what is all this? Kp, we already know. Kc, we already know what those are. Those are just the numbers that would be given to us. R is our gas constant. Now, because we have temperature and we have moles, especially since we have moles, we need the R that has moles. So it's the 0.08206 or 1, and that's here. Running out of room, let me rewrite it. Liters, atmosphere, mole, Kelvin. So remember, that's just on the back of your periodic table or in the back of your book there. T is going to be temp. Can't write today. And if this is in Kelvin, then your T needs to be in Kelvin. Now let's do what delta N gas is. So delta N gas is going to be the moles. So change in moles for your gas. That's what it means. Delta means change. N is your moles for the gas. So the first is going to be the N of the gas for the products. That whole thing minus the N of the gas for the reactants. So if I'm looking here, those numbers are going to come from my coefficients. So in this case, they would be for my products, I would add this coefficient and this coefficient. So C plus D, add those coefficients minus A plus B. So it could be a negative number. So you could work this out and get a negative exponent for your N of gas. All right, so let's work one out. Calculate Kp from Kc for the following reaction. I gave you Kc and I gave you the temperature. So let's ask, what am I looking for? So what am I looking for? Yep, Kp. What did they give me? A reaction, Kc, and temperature. So what should jump out is that I'm looking for Kp, they gave me Kc. The only way that I can find Kp is I can work it all out and plug stuff in, like I can plug in the pressures here and solve, but I don't have any pressures whatsoever, but I have Kc. So if you have one, you could find the other. So I need to know what that equation is that relates one to the other. So Kp is equal to Kc RT delta N. All right, so I'm looking for Kp. They gave me Kc. R is a constant, so I go on the back of my periodic table and I write down my R. So my R is my 0.0821. And we don't, ATM, liter, mole, Kelvin. T is my temperature. Okay, I have temperature. Is it in the right units? So since my R is in Kelvin, this needs to be in Kelvin, so 273.15. So that gives me 298.15 K. And then I need moles. The only way I can get the moles is from a balanced equation, which I have. So let's plug stuff in. Kp is equal to Kc, 5.8 times 10 to the 5th, times R. Now, you might want to use like a big bracket here because you want to keep the R and the T in this parenthesis. So R, T, in the big bracket, and the delta N. So it's products minus reactants. So products is just a 2. So 2 minus 3 here and a 1 here. So 2 minus 3 plus 1, which is 4. All right, so let's simplify things. And here I'll write out the delta N in case you're confused. 2 minus 3 plus 1, so 2 minus 4. All right, let's simplify. So first, we want to simplify my R times my T. So R times T is 24.4781, and then 2 minus 4 is a negative 2. It's okay, we can get a negative. This delta N only goes to RT. So make sure that this number is only going to be the power of your R times your T, not this. So now let's simplify that part. So 24.4781 to the negative 2 is 0.001669. And then 0.001669 times 5.8 gives me a KP of 967.99. That's my answer. So now we know that that is really big compared to 1, and we're good to go. Alright, so we're going to stop there, and then the next video we're going to talk about how do we predict which direction the reaction is going to go. Alright, see you soon.